Data processing has been a continuing activity since the beginning of mankind. As humans, we absorb information and experiences around us and are able to filter, manipulate, modify and apply them to our daily lives. Nowadays, we use tools and gadgets for various applications to get better speed and accuracy and to remove the fatigue from repetitive and voluminous tasks. When thinking about processing applications, people tend to compare the two electronic calculating devices, namely the calculator and the computer. The calculator, however, remains a dedicated device capable only of arithmetic data processing operations, whereas the computer is a general-purpose device whose capabilities extend beyond simple arithmetic. The computer is capable of accepting raw information or data and generating the processed result, manipulating textual data and calculating numeric equations, comparing two items and following a logical course of action based on the result, storing the data or the result for future use and retrieving it when required. These can be summarized into four broad application areas, which are input or output applications, text manipulation and calculation applications, logic or comparison-based applications, storage and retrieval applications. You will now learn about the use of computers in each of these application areas illustrated with suitable examples. Input and output applications involve accepting input in the form of organized data, processing this input and printing the output. The most common application of this is in printing of mailing labels. The source data is manually keyed in from letterheads, visiting cards, etc. into an organized structure of people's names, postal addresses and contact details. This organized structure of data about people and organizations is called a database, which is generally stored on various media like floppy disks, tapes or even on the internal disk of the computer. The computer is able to access this database and maintain it by adding new contacts, deleting redundant ones, or updating information. The database information is processed through a special set of instructions called a program to format the individual entries into mailing labels. Final result is then printed on paper to be cut and pasted. You have seen here how the computer is used to perform a repetitive task of taking in information as input, maintaining and designing it for suitable output. Perhaps the most common use of computers in any application area is the manipulation of text. By and large, one can categorize text manipulation packages into three types, that is, outline packages, word processing packages, or data communication packages. An outlining package, as the name suggests, helps one to create a textual outline of a project and build onto it systematically towards the final result. For example, one can start with the raw thoughts on launching a new product in simple points. As more facts accumulate, these are expanded into the detailed body matter. All the text thus arranged can then be labeled and repositioned into an outline structure with major headings and subheadings. The textual manipulation in this example can be in terms of adding, deleting or modifying text, promoting or demoting headings and subheadings. Here you have seen the example of a text manipulator package through which one can create an outline for one's thoughts on a product launch. Handwritten communication has existed ever since man learned to write and was able to use written matter for information interchange. Not only was it time-consuming, it lacked neatness, aesthetics, was expensive and more importantly lacked speed, particularly where large amounts of written communication was involved. This is another application area where a text manipulator is useful, that is, word processing. Let us take the example of a communique going to all the clients announcing the new product launch. A word processor helps to create a standard letter that can announce the product to a large database of clients. The word processor can beautify the text in terms of applying different types of styles, colors, highlights, paragraph indents, etc. One can then print out as many number of copies of the same letter and send it to the people for whom the mailing labels were created with the input-output package. You have seen here how a word processor manipulates text by applying aesthetics to the way written matter is presented. The third category of a word manipulation application can be seen in the use of a data communications package. Traditionally, data was exchanged in printed form or by speech over the telephone or in the physical transfer of storage media such as floppies. Today, a major chunk of data exchange takes place over communication lines such as the telephone lines, cable connections, fiber optic lines, etc. The data transfer may be between two physically distant points or within a computer network. Let us assume that the product launch we discussed earlier had to get the final verification from the managers of all the concerned departments which were located in different cities. A data communications package would allow you to compose the message which could then be sent over a communication line. It uses EMMS, that is, Electronic Mail or Message Service, to store and deliver messages by the digital medium. The responses from all the managers would also reach you in a similar format over the same communication line. Here you have seen the application of a text manipulator that composes, sends and receives electronic message or mail over communication lines. The text manipulation or input-output applications usually do not cover any aspect of mathematical calculations. Calculation packages are very popular in the fields of payroll computation, sales forecasting, performance analysis, budgeting, and balance sheet preparation. Some calculation packages are dedicated to a particular task, such as payroll, balance sheet, bank account updating, billing, and payment. Some others, like a spreadsheet package, allow you to define equations and relationships between cells of numeric information so that new data being entered automatically gets calculated and displayed in the result. Yet another kind of calculation package makes use of graphical charts to translate numeric values into effective geometric displays of bar, line, and pie charts. These are typically seen in presentation packages that project sales forecasts and annual budgets. These were examples of how computers are used for data processing in calculation applications. The ability to compare two items, be it numeric, non-numeric, or symbol-based, is the greatest virtue of computer. Comparisons between items can be tested for matches-mismatches or lesser-greater values. Based on the result, the computer applies logic in selecting a specific course of action. For example, let us assume that you decide to call all the clients of Mumbai for a roadshow on the new product launch. You would have to print mailing labels only for those clients from the database whose address has Mumbai on the city portion. A simple logic command for this would be if city equals Mumbai, then print mailing label or else skip to the next client name. Here, the computer compares the entry against the city portion for each client name and applies the logic to send only those addresses that have Mumbai for label printing. Since this is a repetitive task, we can define a loop structure for the number of times we wish to perform the task. This is again done by comparing the values of the number of client entries processed against the required number to be processed, or by comparing if the database entries has reached the end. In this example, you have seen how the computer in printing selected mailing labels performs the comparison and logic applications. Other uses of logic or comparison applications can be seen in the areas of order entry, shipping and billing system for customers. Information is stored primarily for its retrieval value. We record and maintain facts only because we may wish to revert to it later. The retrieval value of handwritten and printed material archived and stored in libraries, office stores and such places offer such problems as loss in fire and natural calamities, illegibility of ink over time, requirement of large storage rooms to keep the material, expenses incurred in maintaining its safety. The two issues that need discussion with regards to data storage are what to store on and how to organize the storage. Computers allow us to store data in a digital form on magnetizable or optical media such as tapes and disks with incredibly huge storage capacity. These are often kept in online storage units where they are always available to the computer for immediate information retrieval. The storage and retrieval application packages that allow us to maintain data in an organized manner fall into three basic categories: file or database management packages, project management packages, and memory resident packages. File management systems or FMS and database management systems or DBMS allow us to store data in an organized repetitive structure called a database. The database comprises records for each individual client or organization. Each record is further divided into fields to store a specific data item like name, company, or city. The organized structure comes from the fact that each record has its fields in the same order or sequence. Another storage application can be seen in project planning and monitoring. For example, if you were to set up a plan for building a new factory, a project management package would help you to store data that needs to be accessed frequently. It would store date-wise schedules, resource allocations, and planned cost versus actual expenditure. Some applications have an instant storage and retrieval facility. These are memory storage packages that can be invoked by a single keystroke and are designed to perform instant tasks. For example, you may be working on a presentation package and need to quickly total a column of numerical figures. It would be very useful for you to invoke the calculator, a memory storage package, to compute the sum. Other applications of memory storage packages can be seen in the use of contact lists, to-do lists, schedulers, etc. While these are conventional storage applications, the use of digital or electronic media has allowed us to store music, sounds, images, text and numbers, and movie clips. You must have heard about the Encyclopedia Britannica and National Geographic volumes being available on CD-ROMs, thereby extending the access to voluminous knowledge right into your computers at home. Increasingly, the computer-human interaction is becoming more diverse and real-life-like. Any computer, be it large or small, has two primary components: hardware and software. Computer hardware comprises all the tangible physical components: mechanical, magnetic, electronic, electrical devices like chips, wires, bulbs, circuitry, etc. These are generally integrated into three distinct elements based upon the functions they perform: input-output devices that allow data to be entered into the computer, like keyboard or mouse, and devices that allow us to get the output, like monitor or printer. Processing unit that performs the actual manipulation, calculation, sorting, comparing, and logic, generally called the CPU. Storage devices, called drives, that store data on media such as floppies, hard disks, CDs. Computer software comprises the set of instructions, documents, procedures, and routines based on which the computer performs tasks and processes data. Like hardware, software can also be categorized into types based on the functions they perform: system software and application software. Neither the hardware nor the software can function without the other, quite like a car with a driver. The car, akin to hardware with all its physical parts, has the potential to be driven. But it is the driver, akin to software, who can actually put it into motion by starting it, deciding how to change the gears, what speed to drive at, and which road to take. The hardware components, being the physical components, run on power supply. They require regular maintenance, replacements, and upgrades for consistent and improved speed and power. Software, being a set of instructions, is usually written once for a specific task. Software is usually stored on chips, disks, and floppies. It is of no use unless the instructions are transferred onto the computer hardware to be acted upon. As mentioned earlier, software can be categorized into two distinct types based on what they're designed to do: system software and application software. In common parlance, the terms software and program have come to be used interchangeably and refer to a set of instructions. Simply put, system software comprises the set of instructions that are required to make the various components of the computer work in the routine manner. Application software comprise user programs that are used for specific application areas such as payroll, inventory systems, airline booking systems, financial accounting, etc. We can perceive the working of the computer system in terms of layers. At the outermost layer is the human being who uses the computer. At the inner core is the hardware circuitry. Between the hardware and the human is a broad layer of software, which is further divided into two layers. The outer layer, closer to the human interface, is the application software layer, while the inner layer, closer to the hardware core, is the system software layer. The interpretation of instructions in the application software is done by the system software and then related to the hardware for performing the specified task. Nevertheless, there are certain routine tasks which are given by the human which are directly handled by the system software, such as input-output operations, storage tasks, memory, display tasks, etc. So, the system software instructions run the computer system and assist the application programs while they're running. Preparation of this intricate system software is almost always left to the computer manufacturers and independent software suppliers. The system software layer can be further broken into two categories: the operating system or OS and utilities. The operating system or OS is an integrated set of specialized programs used to manage the resources and overall operations of a computer. The OS manages the hardware resources, software resources, and interfaces them all. In fact, the hardware is useless without the OS. Whenever you buy a new computer, the first software that needs to be loaded within it is the OS. Thereafter, the OS manages the loading of other application software. It is the OS that forms the link between the user programs and computer hardware. Having understood the concept of an operating system, you can now relate it to commonly used OSs of yesteryears and those of today. The CPM80 was a popular OS for personal computers developed in 1970. It was later upgraded to the CPM86, although its use was restricted. The next most popular OS was the MS-DOS, or the Microsoft Disk Operating System, developed by Microsoft Corporation and used extensively on IBM machines. While these two OSs were sufficient to handle single user needs, the more complex, sophisticated and powerful OS of the day was Unix, developed by Bell Laboratories. Unix was designed primarily for larger machines, minis, mainframes and supercomputers. However, its power and multifaceted capabilities have made it useful even on personal computers. All the OSs mentioned so far had a dry and prompt-based interface. The latest popular OS that is radically different from its predecessors is the Windows-based OS with a graphical user interface. Its use of symbols and easy mouse-clicking features has made it popular and easy to use for people in all ages and all application areas. So far, we have viewed computer systems in general and have seen that software can be classified into system software and application software. In order to develop software, we require some instruction rules which the computer can understand. It is for this purpose that we also have computer languages. Just as any spoken or written language has characters and grammar rules of usage, a computer language is a system of communication composed of characters and grammar or syntax that permits one to use it in defining a task or command. The user can enter commands in a language that the computer can understand. These computer languages exist in the application software layer and are interpreted by the system software. The earlier computer languages were very complex and required specialized people to write programs in them. Machine language, in which all instructions had to be written in codes of zeros and ones, and assembly language, which used mnemonics for repetitive commands. The development of simpler computer languages came with the evolution of high-level languages or HLLs and 4GLs or fourth generation languages. These were more oriented to common data processing, mathematical and scientific problem solving. Examples of HLLs are BASIC, Java, C, C++, amongst many others. The simplicity in learning and using these languages to develop application solutions has paved the way for an explosion of programmers worldwide. Assembly and high-level languages required conversion of the programs written by the users using convenient languages into machine-level codes. This translation into the machine language was done by translating programs or translators, which are part of the system software layer. Application software, as you know, is designed for use in a specific application area such as the payroll, inventory systems, airline booking systems, financial accounting, etc. Application software can also be broken down into two categories: pre-written software packages and customized software packages. Pre-written software packages are usually developed by specialized programmers and software firms with a global presence. They are available from the producers or from retail stores, mail order houses, and are available in a wide range with wide potential of usage. Customized software, on the other hand, are designed by software consultancy firms to meet the specific demands of an organization or individual. Pre-written software can be further divided into two types: single function application packages and integrated function application packages. Application software packages that perform a single task, such as processing words or designing or data analysis, are known as single function application packages. Single function packages can be general purpose, such as word or text processing packages, example Notepad, WordPerfect, or desktop publishing systems, MS Publisher or CorelDRAW, spreadsheet and data analysis packages, examples Lotus 123, SuperCalc, etc. Or they can be special purpose, designed for a special class of users, such as human resource management software, electrical contracting software, law office software, medical office software, games and hobby packages. Integrated functions applications packages combine many of such general purpose package modules in a single product. With an integrated function package, it is possible to use a common set of instructions to share data and move material amongst several applications. For example, MS Excel integrates word processing, data analysis, calculation, charts, and automated features into a single product. We just saw how general information needs may be satisfied by pre-written software packages available off the shelf at reasonable prices. Buying software is very much like buying clothes. For some of us, the generally available ready-made clothes are sufficient for our clothing needs. But for some of us, clothes need to be stitched as per specific measurements for better comfort and a better fit. Likewise, pre-written software do not always answer the requirements or needs of all people and organizations. This results in the need for creating customized software that can address exact requirements of the firm. Typical application areas that would require the creation of a customized software are a finance manager wishing to further reduce billing errors accruing from the use of pre-written software. In company mergers and acquisitions, a new system needs to be developed to handle the IT requirements of both the firms. Production manager wants to further improve the quality and details of a product information. A school wishing to develop an online information access system for the students. In short, customized software is useful in large organizations that are attempting to create a new program or system, improve or modify an existing system, integrate procedures in an unparalleled manner. Being so user-specific, the development time and effort is more. Hence, customized software tends to be much more expensive and takes longer to be commissioned than pre-written software. Also, the risk of errors and improper fit is higher in customized software if either the needs were improperly defined or the product is poorly designed. Any computer-based information system is created by and for people, the most important element in the system. The entire system revolves around people who may be specialists in the data processing department or non-specialists like clerks, assistants, managers who make suggestions for the procedures and use the results. The other mandatory essential elements include the necessary input data, the required hardware, the software programs that will process the input data into the desired result or output, the various complementary programs that will enable the hardware to accept input data and follow procedures. Even in a customized solution, it is the people who put the computer to use and determine processing needs, provide input data, design processing procedures, select hardware and software, write computer programs, and use processed outputs. The very first step in acquiring software is to answer the question, what are my needs? Even if you were to go and buy a pre-written software, you would probably browse through the rack of similar products and study each one's features to see which one best suits your needs. Likewise, in customized software, the very first step is to identify one's need. In all, there are 7 steps involved in this process: problem or need definition, system analysis, system design, programming analysis, program preparation, program execution and debugging, documentation and maintenance. Needs arise out of problems, and problems arise due to the introduction of new systems or revamping of old ones, or due to combining parallel or unparalleled systems. The problem has to be first studied and a solution is required to be developed. So, problem definition details the description of the problem and defines the need for specific changes. This is done by users and specialists. The problem definition is written down and approved by all the people concerned in developing the customized system. After the problem has been identified and noted, a separate study team then analyzes the data regarding the current processing operation. This study team typically has 3 profiles in addition to the people working in the system analysis department. Specialist who is knowledgeable about the information needs of the department that is affected by the change. System analyst, an IT specialist who knows all the technicalities in the analysis, design and implementation of the proposed system. Auditor, who ensures that the system is built with the required accuracy and security. This team performs the system analysis in a detailed stepwise manner. First, they go about collecting the data about current processing operations. The accuracy, updatedness and completeness of this data is of utmost importance since it will be treated as the input. Second step involves the creation of a system flowchart illustrating a macro view of the data flow and sequence of operations in the system. In this stage, emphasis is laid on the input documents and output report. The third step requires the team to analyze the findings. While analyzing the current system operations, it is of vital importance to identify the essential data and procedures required for a new approach. It is also necessary to identify the weak points and drawbacks in the current system to prevent their being carried into the proposed new system. So, the entire stage of system analysis revolves around the study of the existing operation to learn what they accomplish, why they work as they do, and what roles they may have in future processing activities. The system design stage is perhaps the most challenging one, since this is when a proposed solution to the problem is laid out in a well-defined process. Various factors have to be considered while designing the system: personnel resources, financial resources, availability of equipment, alternative procedures to carry out a specific job, effect of proposed changes in one department or application on the others. The system design creates the alternative solutions that will satisfy the problem definition by evaluating the choices, drawing up the specification for the chosen alternative and its effectiveness. After the approach for the design has been finalized, the system designers then prepare new design specifications, complete with the desired output, the required input, and the processing procedures required to convert the input to the desired output. The new design specifications is the basic input for the programming analysis stage in the system study approach. Programming analysis is the process of breaking down the new design specifications into the specific application tasks that the computer will be required to perform to satisfy the study goals, that is, input-output tasks, text manipulation and calculation, logic and comparison, storage retrieval operations. At this stage, analysis tools may be used to clearly illustrate the design. These include program flowcharts, which evolve from system flowcharts, and algorithms with finite number of steps. The program flowchart provides a detailed diagram showing how individual processing steps will be performed within the computer to convert the input into the desired output. The output from the program analysis stage, which may be in the form of flowcharts and algorithms and other tools, provide the input for the program preparation stage. The most suitable programming language to handle the required processing duties is chosen. Then, the operations outlined in the programming analysis stage are coded in the selected programming language. The program codes are written and compiled as per the processes defined. The compiled program is run with sample data and checked for errors. This stage of executing and debugging is termed as program implementation. This stage may require the program to be executed and debugged several times till the software appears to be running properly and giving the desired results. The changeover to the new system is only made when all the people concerned have verified the output across many sample runs. Once the program switchover is done, documentation is of prime importance. All the program listings, operating instructions, and other program-related printouts are compiled into an operations manual. This operations manual will help the organization in the future for modification and reference, since the people involved in the creation of the customized program may not always be around in the same firm or location. Program maintenance is an ongoing process that ensures that the new system is running correctly and efficiently. The program is checked regularly for any errors introduced or caused by it. Since new needs arise over time, these programs have to be periodically updated or new systems have to be designed. Needless to say that the need for a significant change in the system may result in the entire system study process being repeated from scratch.